All right, here's two questions with regards to polynomials. The first one asks you to find the zeros and state multiplicity of each. They give you this function here. It has an x to the fourth, and it's positive, so it's got to start high and end high, have that kind of shape to it. They don't ask us to graph it. Anyway, so it's an x to the fourth, but they want us to find the zeros of that. And we're not sure how to deal with an x to the fourth there, but maybe it can be factored just like a function like this could be x squared minus 27x plus 50. I could factor that x and x. Two things that multiply to 50 add to 27, I think, are 25 and 2. Both would be negative. So if I can factor this, perhaps I can also factor it when it's an x to the fourth, minus 27x squared plus 50. So what would I put in the first slot there? Hopefully you're saying x squared. That's correct. And two things that multiply to 50 add to negative 27. So negative 2 and a negative 25. And if I check that, this times this, x to the fourth, negative 25, negative 2 would be negative 27, yeah. And this times this, positive 50. Yeah, so this is correct. So that is the function in factored form. Now, if they want you to find the zeros of the function, that means set f of x to 0. So we're going to change that to a 0 and then solve the equation. Well, this is an equation now where I have the product of two things equal to 0. So one of those two things, either this one or this one, has to equal 0. And then I just solve both of those quadratic equations. This one, I think the easiest way to do is to use the square root principle. So first thing I'll do is I'll add 2 to both sides. So I'll get x squared is equal to positive 2. And then I'll square root both sides. And so on the left side, I just have x, which is what I want. But then when I use the square root principle, I have to remember that I always put a plus or minus there. So this would be a plus root 2 or a minus root 2. So there's two answers there. And then this one, move the 25 over, square root both sides. Oh, this is nice because it comes out to a plus or minus 5. So those are the 4. So there's 2 more there. So there's 4 zeros for that function. Now they say what's the multiplicity of each? Multiplicity is just when you have doubled up. So none of these are doubled up because I have a positive root 2, a negative root 2, a positive 5, and a negative 5. None of those are the same. Same numbers but different signs, but that doesn't count. So they're not the same. Therefore, you'd say these are my 4 zeros, and the multiplicity of each would be 1. Now, if you wanted to graph this just for interest, it's a plus 5 and a minus 5. Root 2 would probably be about in here somewhere, negative root 2 about there. So if I wanted to draw this thing, I'd come down, come up, come back down, and then come back up. That's probably what the graph would look somewhat like. Another point to make on that, and they didn't ask in the question, but this point here where it crosses the y-axis is always this number right there. So it'd be a positive 50. Okay, now let's go to a question where I guess it's sort of factored out, but they're asking us to find the degree and the leading term of that function. It seems sort of hard to multiply that all out, but like you did here, this is good. So you've multiplied part this time this, so when you multiply common bases, you'd add their exponents. So this should be a 10. And then this is correct. But probably the only thing I want you to take, if we need to find the leading term, really is that number there. So for this first one, when I multiply it out, I'll just write this down, and it's squared. when I multiply it out, the leading term is going to be x to the 10th plus some other stuff. Okay. Now, if I take the next one, x cubed plus 3 all to the cubed, that means there's 3 of those. So let me write all 3 of them. And if I go this times this, that would get me an x to the 6th plus something. And then again, if all they're asking for is the leading term, I don't care about that something. It's the leading term thing that I'm going to have. Okay, so that's these two multiplied together. Then I have this one, x cubed plus 3. Okay, now if I FOIL this times this is going to give me an x to the 9th plus something, whatever that something is. So this part here gives me an x to the 9th plus something. So now if I FOIL out all that, which I'm not going to do, but I'm just going to FOIL out the front guys, this times this would be x to the 19th. Plus, I'd have a bunch of other stuff there. But they don't care what that stuff is. All they're looking for is the leading term. So the degree is going to be 19. The leading term will be 1x to the 19th. And I think that's all they're asking. All right, hopefully that helps you with that question.